How's it going, Algebra 1? It's Mr. Knight. We are going to review graphing and substitution, kind of tie all this stuff together. And we're going to start with the types of solutions. So there's really only 3 types of solutions that you're going to come up with. You'll either have one solution, no solutions, or you'll have infinite solutions. And there's kind of different ways of looking at these graphically. So again, the whole goal with graphing and substitution, our whole goal is to solve for x and y between 2 given equations. We've already seen that we can graph those equations, and those equations are representing lines. So for one solution, that is when our graphs intersect. That means they cross. So you'll have, for one solution, this is when your graphs cross. And so your answer is going to be a point at where they cross. That is an xy point. So you'll have one xy point for your solution. Okay. Let's look at no solution. This is when your graphs of your lines, this is when your lines never cross. They are just chilling by each other, but they're never going to ever meet up. So sad. But they have no solution. And then the last case is infinite solutions. This is where your lines are crossing at every single possible point, aka they're right on top of each other. So we might have a line like that. We might also have the line behind it, since they are the same exact line. Okay? They're right on top of each other. Okay? So now let's think about like a description for these, because we want to kind of figure out what exactly is going on. We want to be a little bit more specific. So where this occurs, this graph right here is giving us that one solution x comma y, and those lines are going to have different slopes, and they're going to have different y-intercepts. Okay. So basically what I'm going to put is, since slope is represented by m, I'm going to say that the slope of equation 1 is not equal to the slope of equation 2. And I'm also going to do that with its y-intercept. The y-intercept of equation 1 is not equal to the y-intercept of equation 2. Okay. When it comes to no solutions, if lines are parallel to each other, they are slanting at the same constant rate. That means they have the same slope. Okay, so that means the slope of 1 is going to equal the slope of equation 2. And then finally, if they're right on top of each other, not only do they have the same slope, they also have the same exact y-intercept. They would have to, if they are the same exact line. Okay, so let's think about that algebraically too. With solving for these guys, we've been doing that with substitution. So when you're not actually given the graph, there's interesting things that kind of emerge. So we'll start with one solution. You will get an answer. You're going to get an x comma y. Okay, so you're going to get an x equals something and a y equals something, and everything's going to be gravy. Okay, no solution, you might get something like 12 equals 13, something like that. We know that's not true, and if you get a contradiction, then you know that you have no solution. And then finally, if you do get something like 12 equals 12, we know for sure that that's true. So if you're going through substitution, you get 12 equals 12. You know that you have infinite solutions for your equations. So let's go ahead, let's go over some examples. Keep this handy. You can use this on your quiz. You will definitely be asked a question on your quiz about this stuff. Okay, so just keep this in mind. And it's a gimme problem if you're able to just have this. Okay, let's take a look at some equations. I have 3 examples for you, and we have practice problems. I'm not assigning them for homework, but I'm assigning them for extra practice before you tackle your quiz, so take advantage of that. So if I have a system of equations, I might see something like this. Y equals x plus 4 and y equals negative 6x minus 3. Now, before we go ahead and graph them, we're also going to do substitution with them. So for these 3 examples I show you, we're going to see the graph and the substitution. Okay. With the graph, the whole idea is to get them into the form y equals mx plus b. Sounds like I'm beating a dead horse with that, but it cannot be stressed enough that y equals mx plus b is how we graph our equations. It tells us what to do, right? So if I have these 2 equations, are they of the form y equals mx plus b? Yes, they are. Y equals m, which is 1, x plus b. I'll even put the 1 right there. And y equals mx plus b. Okay, even though it's a minus, it doesn't matter. It's still plus b. So the first thing we do is we plot our y-intercept. It's always going to be of the form 0, comma b. Okay, so identify what your b is, and that's going to go for your y-coordinate at this point. Okay, so for example, if I'm graphing this first equation right here, my b is 4. Therefore, my first point is 0, comma 4. It is that straightforward. Okay? And then I'm going to use rise over run from my slope m to get other points. So if I look at this equation, we have y equals 1x plus 4, and I compare that to y equals mx plus b. Well, the m has to be this 1, and usually we represent that as a rise over run. The reason we do that is for the graphing part. We know that when you're rising, you're going up and down. When you're running, you're going left and right. Okay, and that tells us how much we have to go up and down, left and right from this point. Okay, and we can keep doing it over and over and over again. So if our slope is 1, I need to represent that as rise over run. So I could just plop another 1 underneath it. 1 divided by 1 is still 1. It's just an equivalent form to write it so that I know I'm rising up 1 and I'm running 1. Okay, and that's what I'm going to do. I'm going to rise up 1 and run 1 right here. I'm going to go up 1, the right 1, and I start getting some points. I can also go the other way. I don't have to just treat it as 1 over 1. I could treat it also as negative 1 over negative 1. Why can I do that? These simplify to positive 1, which means I can go down 1 and left 1. I go down 1 and left 1, down 1 and left 1, and I can get a line that way. Okay. But what's my goal? My goal is to solve for x and y between 2 equations, right? So I want to see where both these lines are going to end up crossing. So I got to graph the other one as well. We have y equals negative 6x minus 3 for that one. Again, what's my first point? It's 0, comma b. My b is negative 3. Therefore, my first point is at 0, comma negative 3. Okay. My slope is just negative 6, and very similar to the 1, I want it as a rise over run, so I'm going to put it over 1, just like that. That tells me I'm going to go down 6 and to the right 1 from that point. Okay, so I'm going to go down 6, 1, 2, 3, 4, 5, 6, and I would go to the right 1. The problem with doing that is this line is over here. I want to go that way, so I need to manipulate my signs a little bit. So to write an equivalent form of negative 6, think about your properties of your signs when it comes to division. I can switch the signs. I can make this a positive 6. I make that negative 1. 6 divided by negative 1, still negative 6. So now this tells me, hey, I can go the other way. I can go up 6, 1, 2, 3, 4, 5, 6, and I go the left 1. And it's really good I did, because now I can clearly see they are crossing at this point right up here. And that point is going to be negative 1, comma 3. And that is my solution. Right? I would write it as an xy point, okay? Just as you would with substitution. Speaking of substitution, let's do it with these equations and see if we can get this. Because if we do, hey, we're onto something. Something's going right, okay? So let's check this guy out. We're going to substitute. The whole idea with this is with substitution, and maybe it wasn't clear enough with the video, but you're just taking an expression for x or an expression for y, and then you're plugging it into that x or y in the other equation. That's what you're doing, right? It's just like you've kind of been solving equations normally. If you know x is equal to 3, you can plug 3 in for x, right? But sometimes we don't have that, right? With two equations, we don't have like y equals 5 or something like that yet. We might be given something like this. But I do know that y equals x plus 4. So if y equals x plus 4, I can plug it in for this y right here, right? I also know that y equals negative 6x minus 3. So if I wanted to, I could plug the negative 6x minus 3 in for this y. It does not matter which I choose. In fact, I'm going to do it that way just to illustrate that point. So I'm going to do negative 6x minus 3. That's going to go in for this y right here. And it's going to be equal to x plus 4. Right? I just replaced that y with negative 6x minus 3 because it tells me that that's what y is equal to. Right? So now I have this, and now I need to find out what my missing variable is, x. I'm able to do so. Look, I have like terms on both sides of the equal sign. Okay? So I can think about undoing something here, but what I do to one side, I do the other. So if I wanted to undo this negative 6x, I could add 6x. I'm going to add 6x to both sides so it stays equal. Right? If I add 1 to one side and not the other, it's not equal anymore. Right? I got to do this to both sides. So these 6x's will cancel out to 0, and I'll be left with negative 3 is equal to 7x plus 4. And now I have a two-step equation. We're going to go ahead, we're going to undo the addition first. I'm going to subtract 4 from both sides. Negative 7 equals 7x. I divide both sides by 7, so I get x is equal to negative 1. And that's good because that was our x coordinate when we found that point. So now what can I do with this? Well, just like I said earlier, if we knew that x is equal to 3, I could plug it in for here. But x is equal to negative 1, so I can plug it in for this guy still. It's just the same thing, except instead of 3, I'm saying negative 1. So now we have y equals negative 1 plus 4, and negative 1 plus 4 is just 3, so y equals 3. And I can write my answer as negative 1 comma 3. Okay. That's all there is to it. When you have both of them that are y equals, this is exactly the skill that you're going to be doing when you get there, when you get to the quiz. Okay. Let's see another example. Let's solve this system. Yeah, we have y equals mx plus b. That's awesome, but this guy is not awesome, right? That's standard form, we call that. And we can't do much with that, at least not yet, right? Standard form looks like ax plus by equals c. A, b, and c are just numbers, random numbers. So I'm about to solve every standard form equation that's possibly out there right now. So I'm going to do it with just symbols, okay? So what I want to do, there's two steps, and I've been saying these two steps over and over again, and you should have them, okay? First step, subtract or add, but in this case subtract because it's the opposite. Subtract ax from both sides, so these ax's cancel, and I'll be left with by is equal to, well, negative ax plus c. I can't combine those. They're not like terms. They both don't have x. And then the next thing I do is divide every number by b, or whatever's in front of y. So these b's will cancel, and I'll be left with y is equal to negative a over b. Doesn't matter what those numbers are. They're going to end up being your slope m, and then whatever your c divided by b is, that ends up being your b for your y-intercept. These b's are different, okay? This b's for your y-intercept. And that's what we could do. So if I take this guy, I can't graph it yet until I change it to y equals mx plus b. So let's do exactly what I just laid out there. I'm going to minus 6x from both sides. I'm left with negative 3y equals, I'm going to put my negative 6x first, because I want it to be y equals mx plus b. And now I'm going to divide everything by negative 3. Those cancel, and what I end up getting left with is y is equal to negative 6 divided by negative 3. That's positive 2x. And then this will be minus 3. Okay? Now it looks like y equals mx plus b. It looks just like it. which is good because now we can graph it. Okay, so let's start graphing it. So first thing, I plot 0, b. I plot 0, b. So I'm going to plot 0, -3 for this equation. That's going to be my first point. Okay, I also know my slope is equal to 2, but I want to write that as a rise over run. So I know how much I'm rising and running, so I can write that as 2 over 1. Okay, so I'm going to rise up 2, and then I'm going to go to the right 1 because it's positive. Up 2, right 1, up 2, right 1, up 2, right 1. And keep doing that. I can also go the other way. How do I do that? I can make them both negative. So I can go down 2, left 1, and we'll call it good right there. That looks like I have enough points to get that sketch. And let's go ahead, let's graph the other one too. The other one was, I'm going to move up here. The other one was y equals 2x minus 5. So let's go ahead and let's, again, my first point is going to be 0, -5. 0, -5 is down here. And hey, my slope is the same exact thing. Let's go ahead and let's graph it anyway. So I'm going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And you're probably getting the idea of what's going on, right? These guys have the same exact slope, and they're never going to cross, right? And since they never cross, I can declare that there is no solution, right? That was based off our chart. Remember, we said if the slopes are both the same thing, and they both are, they're both 2, these guys are going to be parallel, right? Just like we said graphically. And if they are parallel, we're going to end up with no solution. Okay? We're still going to use substitution because I want you to see algebraically that we get something like 12 is equal to 13. Some kind of contradiction where you know it's not true. Okay? So let's see that. Alright, so now with these guys, it's not exactly like the last substitution problem we did. Remember, both of them were y equals, which was nice. So we could just say, hey, there you go. Between these two, we actually have a choice to make. We can manipulate this guy if we want to, but we really don't have to. And here's why. We already have an expression for y. We know that y is equal to 2x minus 5. So instead of going through the trouble of manipulating this guy right here, I don't have to. I'm just going to plug 2x minus 5 into y into this equation right here. Okay? But I'm going to plug in the quantity, right? The whole thing. So I got to plug it in, the entire thing. Basically, parentheses is what I'm alluding to. All right, so we'd end up getting we end up getting 6x minus 3y equals 9. Let's go ahead, let's plug in our y. So 6x minus 3. This y is being multiplied. So I'm going to put this entire thing 2x minus 5. And that's going to be equal to 9. And that's good that we know that it's in parentheses. That lets me know I got to distribute. Okay. When we distribute, we take this number right here, the sign and everything, and now I'm going to multiply it to each term in there. Okay. So I'm going to get 6x minus 6x. Negative 3 times negative 5 is plus 15 equals 9. And so 6x minus 6x, that just equals 0. And I'm left with, hey, 15 equals 9, which we know that's not true, so there is no solution. Okay. It happens, right? And so that's kind of an idea of, that's a way for you to actually see it, see what I mean by that. Okay. You've encountered that on your homework. Kind of wanted you to discover that on your own, but here we are, right? Example 3, that's our last one that we're going to do. We're going to solve this system. Now, looking at both of them, they're both in standard form, so we have some work to do. We need to turn those into y equals mx plus b. And we do it the same exact way, right? Same exact way. That has not changed. So I'm going to take my first equation, 2x minus 5y equals negative 22. Right off the bat, I'm going to undo the 2x, so I have to subtract 2x. And so these two x's here cancel. I'm left with negative 5y equals, well, my x to come first, negative 2x minus 22. Okay. Now we're going to go ahead. We are going to add, or I apologize. We are going to divide everything by negative 5. And so we're going to get y is equal to, this is positive 2/5, positive 2/5 x. And then this guy is actually kind of gross. It didn't work out really nice. We're going to roll with it no matter what. The idea is still the same. This is, I'm just going to write this as plus 22 over 5 for right now. Okay, it's some number. All right, but it is in y equals mx plus b form, which is sweet. Let's look at the other one. X plus 7y equals 27. I'm going to go ahead, again, I'm going to subtract x from both sides. We're going to end up with 7y is equal to negative x plus 27. I divide both sides by 7, or everything by 7, and I end up getting y is equal to, there's a 1 technically hanging out right there. This is negative 1/7 x plus 27 over 7. And so we're going to just kind of roll with that for right now. Graphing these are going to be kind of nasty to do. So for this example, I'm going to actually just plot these on Desmos so you can see and get the idea. Okay. I wouldn't give you something like this ever, but this is something that's probably more suited for substitution, which you'll see in a little bit. Okay. But let's see on Desmos what's going on. So we ended up getting y is equal to 2/5 x, not 25, 2/5 x plus 22 over 5. We also get y is equal to negative 1/7 x plus 27 over 7. And it turns out these guys end up crossing over right here at that gross point, which is not fun. That is not a fun problem to do. Pretty gross, pretty gross. And it's even more gross because I didn't even type it in correctly. There we go. Whew. Yeah, that made me a little nervous, guys. All right, yeah, negative 1,4. That's a lot nicer. Okay, we're gonna write that as our answer, and we're gonna compare that to when we substitute. Okay, let's come back. So we're trying to get negative 1,4 from this. Let's see what we can do. Now, with substitution, again, do we have something where we have y equals or x equals? And right now, we do not, right? That's what we want to get. So between these two equations, now we have to kind of manipulate it and change it into something where we get x equals or y equals. I would focus on this one because we already have something where it could be, the potential is there for an x equals, right? A y equals is a little bit more ambitious. We'd have to do a lot more algebra. Let's just do something a little bit easier, right? So all I got to do, and it's similar to how we did standard form, right? If I want to get rid of this 2x, I could subtract 2x from both sides. It's positive, right? Well, I want to undo this. It's positive, so I can subtract 7y. But what I do to one side, I do to the other. So these can't combine, but that's okay. I have x equals 27 minus 7y. Now I have something where it's x equals, right? Now I can plug that thing in, this expression in, for x into the other equation now, okay? And we're going to plug in the entire thing. So let's do that. Let's do that now. So now we have 2, and instead of x, we have the quantity 27 minus 7y. And then that's going to be minus 5y equals negative 22. Now let's distribute this 2 because it's outside the parentheses like that. And so we end up getting 54 minus 14y minus 5y equals negative 22. Let's go ahead. We can combine these because they're like terms. Negative 14 minus 5 is negative 19. So 54 minus 19y equals negative 22. Two-step equation. I can get rid of the times negative 19 or the plus 54, get rid of the plus 54. It's easier. So I get negative 19y is equal to, we're going to get negative 76. And if you put that in your calculator, because I don't have that memorized, you're going to end up getting y is equal to 4. Okay. And so now with that 4, now that I know what y is equal to, I can plug it back into this equation. I mean, I could plug it into this equation, or I could plug it back into this equation, or this equation. I have a lot of choices. Why am I picking this one? It's easier, man. That's why. If I just plug this number in for y, it's literally just 27 minus whatever this number is, right? After I multiply. So now I'll know what x is. So I get x is equal to 27 minus 7 times 4. So that's x equals 27 minus 28. So x is equal to negative 1. So our final answer would be negative 1 comma 4. And that is really good news because that's what we got when we graphed. Okay. So I have posted some example problems for you guys to do. Again, it's not for a grade. It is literally for practice to get you ready for your quiz. That doesn't mean you shouldn't do it. I would say pretty much all of you should be doing it because you need the practice. So take advantage of that. Good luck on your quiz. You're not going to see anything on your quiz that's anything worse than this. That last graph problem, you're not going to be expected to graph something like that where, you know, the numbers don't work out nicely for your y-intercept. But thank God for Desmos because it came in handy. This is Mr. Knight signing off. Have a good weekend.